So we are, this doesn't look quite right. Why is there, okay, it comes up as that. All right, we are looking at functions today. And functions are like a foundational thing that start off like at the beginning of when you start to learn algebra. This should be mostly review. Now, when I say things like that, I realize that you might not remember what you did back in 9th grade at the very beginning of that year. So you know, I'll try to go back over those things. Whenever I first started teaching calculus, I realized I didn't remember how to do any calculus. I had to sit at the kitchen table every night and work the problems that the kids were going to do like the night before. So I know you might forget some things, but it comes back quicker since you've seen it before usually. So a relation is the relationship between sets of values of ordered pairs. So basically it's just like a list of ordered pairs. Ordered pairs being things like 2, 7, or -5, 4 that we can graph on that coordinate plane. A function is a specific type of relation. So an expression, rule, or law that defines a relationship between variables where, where's my pen? Turn the pen on. Each x has one y. So each x value has exactly one y value in that case. In a function, two of the things that we're going to talk about are domain and range. So getting those brains fired up. Anybody remember what the domain is for a function? Anybody in here have Scott Wood? None of y'all had Scott. Huh? Yeah. Anybody have Coach Wood? You had him? Yeah. All right. Did he tell you about domain and range and sing "All My Exes Live in Texas"?
Oh yeah.
And because Dallas is in Texas, and Dallas starts with a D, and D is for domain. There's not as much. He didn't sing "All My Exes"? He used to sing "All My Exes Live in Texas" all the time. I think he spent more time like roaming the halls singing than he did actually in his classroom. But domain are your possible. Oh gosh, I don't know what that just did. This does not work like I want it to work. But that's all I got. All right, possible x values. So that of course leaves range for your possible y values. Something's wrong with my pen. It's like not writing where I want it to write. Okay. So domain being our x values, range being our y values. That's going to be a pretty big thing that we're going to look at. We'll look at it more in depth tomorrow. There. So if we are trying to decide if a set of ordered pairs is a function, such as we've got this list of ordered pairs. Does anybody remember what we're looking for when we look at that list? What? No. Each x can only have one y. So the x's cannot be repeated. So like in this case when we're asking for domain, we're looking for the x values. X values on, I don't know what my pen is doing here. It's like I'm writing lower. I didn't test it out before. No, okay, I'm going to erase everything. What if I use this? Will that work better? Yeah, that does work better actually. So all of those x values are our domain. And so when you write a domain, you're going to use your squiggly brackets. It's real squiggly. And you're just going to list the numbers. You do not write it more than once. So if there is a repeat, which there's not on these, you do not write it more than once. These are in order because they were in order. They do not necessarily have to be in order whenever you write those down. So those are your x values. That's your domain. That's what you can put into your function, the numbers you can plug into your function. The range, let's let me change colors. I don't usually use this one. Oh, yeah. Let's go blue. The range is going to be your y values. So range, I'll work my squiggly brackets here. We got 0, 1, -2, 2, and 3. Okay. Again, if there was one that's repeated, you're not going to list it twice. You'll just put it on that list once. So in this case, what we're looking for, all of the x values have to have their own y value. Now, they could all have the same y value. It could be -4, 0, -3, 0, 0, 0, 1, 0, 3, 0. The y's can be repeated, but the x's cannot. So is this a function? Yes. I've got to try to get my... It's like it's getting worse. What is happening to it? This is debilitating here. Okay. Oh, gosh. Sorry, guys. Now why won't it let me go to the next slide? Oh, I got to exit the drawing. Okay. Now we'll go. All right. So one of the things that we do for functions, when we're looking at a graph, we can use a vertical line test. So a vertical line test tells us if a vertical line touches the graph of a relation only once at each point as it is passed through the graph, the relation is a function. Sorry for my writing here. Now, something you probably haven't done before because it's not Math 1 curriculum is a horizontal line test. It's really the same idea. You just take your line and you turn it horizontally. And if the horizontal line touches the graph of a relation only once at each point, the relation passes the horizontal line test. A relation that can pass the vertical and the horizontal line test is a special type of function. And it is called a one... Now it's below. It was above last time. I'm going to lose my mind. Why is it doing this? This. Okay. Is a 1... This goes on that line, but it's like dropping 1, 2, 1 function. That says 1-to-1 function. There. I wonder if this thing needs a new battery. Alright. Alright, so whenever we are looking at these, to try to decide if something is a function, a one-to-one function, or not a function at all. Now, all one-to-one functions are also functions, but it's just like a special type of function. Then, oh, I need my yards. So, if we take a vertical line and we go across like this, for our function to be a function, our line can only touch one time. So is this first example, is that a function? It is. How many times can we touch? 1. How many times does this touch? Twice. So, and it only has to be at one point. If there's even one point where it hits twice, there's a bunch for this one because it's hitting a lot of places. So for that to be a function, you can only hit one time that vertical line. So that one is a no. That's not a function. Which, that's a no. My pen is going to drive me crazy. Alright. So if it's not a function, you don't even have to check to see if it's a one-to-one function, because it has to be a function for it to be a one-to-one function. If we look at the next one, if I take a line and go across this one, is this one a function? Number 3, is that one a function? Seeing some nods. This one is a function. So if it is a function, so we know we could already go ahead and write down function if our pens worked properly. I cannot even write. I don't even know about here. It will let me type if I do this. Let me see if it'll. Alright, so it is a function. It's not very big. Will it let me change my font size? Probably not. Okay. I'm going to try to get this fixed for tomorrow, guys. Sorry about this. It is definitely a function. We also need to know if it's a one-to-one function. So to tell if it's a one-to-one function, we are going to turn our line this way. And I'm not tall enough to really do it very well. But if we had a horizontal line, is there anywhere that horizontal line would touch more than once? Kind of in the middle, right? Like if I had, I'm going to draw it. No, I'm not going to draw it up here. Like, if you just think about that x-axis, right? At x-axis, we're hitting 1, 2, 3 different times right there. So it only takes one spot where you hit more than once to make it not a one-to-one function. So this function is a function, but it is not a one-to-one function for that. Okay? You guys seeing what we're doing here? Come on. Okay, so this says use Desmos. I told you to put your computers away, so I'm going to graph them here for us. But on Desmos, let's hit, I need a new tab. On Desmos, if we make that a separate tab here, oh yeah, that would be beautiful. And we graph this equation, y equals x squared plus 2. So if I graph this for us here, and we look at it, is this going to be a function? Okay, if we take our vertical line, just hitting one time, it does get pretty steep over here on the end, but it's still only hitting one time, because we got to remember, like, this line, a line technically does not have any width. But to draw it, of course, we have to have width to it, or you wouldn't be able to see it. Oh, let's see what we got here. Hello? Oh, sorry. Thanks. No, I didn't. I didn't do it at all. Sorry. Bye. I didn't do attendance. Hold on just a second here, guys. Probably everybody be here the first day. It won't matter. But. All right. So, identifying functions is important for us to do. It's mostly Math 1 curriculum, but the one-to-one part is what you're going to see in the Math 3. So, like, if you saw this on the EOC, it would probably ask you about the one-to-one function. Function notation you have used before, and it is really important for us to know. And this is going to make it hard for me to write. So you should have seen equations written like this a lot before, where we use this f of x, right? And it's really great to use in math because it allows us to name different functions so we can tell the difference between them. Because if we're going to do a lot of stuff in this class where we're looking at several functions at once. So if we call this one f of x, and this one g of x, and this one h of x, then it's easy to talk about which one we're talking about. Whereas if we just do y equals y equals y equals for each one, it's hard to differentiate there. So whenever you look at your function notation, we usually use an x, but we don't always use an x right here. We could have, another one you see it pretty often is f of t, because if you're ever doing like anything with physics, time is usually your variable that you're using. So they'll use t's a lot. So this right here, is going to be your independent variable, which is what's supposed to go in that box. I'm certain I can't type that. Independent variable. And I know that's smaller than it needs to be for you to see it, but And over here, this is your function rule. It tells you what to do to that independent variable. So like the independent variable is the number I'm plugging in, and then this rule tells me what to do to it. So in this case, my rule is that if you give me a number, I'm going to multiply it by 3, and then I'm going to add 1 to it. All right, so it's the rule that you're using. Function notation, like I said, is very important. It allows for individual function names. I know this is so tiny. Hopefully you're got eagle eyes back there. Also, if anybody towards the back can't see good, let me know after class. I can move seats around. To avoid confusion as to which function is being examined, it also easily identifies the independent variable in a problem. Oh, I can make the font bigger. Here we go. Ooh, we're good enough for here. Okay. So function notation, something important that we're going to use. And the other things that we're going to focus on. What are we doing here? I want to let me go to the next slide. Okay, there we go. I want that to go away. I don't know what I did there. Ignore that there. So evaluating functions. To evaluate functions. Let's see if I got this how I want it. Maybe. We are going to plug in the input for the function's independent variable. And to do that, we will replace the x with the number or the expression. Typically, you're going to see x's, like I said. Sometimes they use different letters. So this is something that you did back in Math 1, right? We are still expected to be able to know it today. So if we have something like example 7, f of x equals 3x minus 5, if it tells us to find f of 4, right? That's what it's asking us for. What is that telling us to do? How would I find f of 4? Tell your neighbor what you do. So tell your neighbor what to do to find f of 4. Or tell your neighbor, I can't remember, I've forgotten everything I've ever known. Okay, if you and your neighbor both think the same thing, there's a decent chance y'all remember it correctly. What do we do? Can anybody volunteer for me what we got to do if we're going to find f of 4? What do we do, Heston?
You got to plug in the 4 and that's as far as you go.
Plug it in 4. That's right. So this is not easy to type. So a lot of times when we do this, we want to do f of 4. This is painful right here to watch, isn't it? Oh gosh, that would be getting on my nerves so bad if I was sitting out there. F of 4 equals. Now that's just a label. That's not saying f times 4. That's just saying we plugged 4 into the function, and then you'll do 3 times 4 minus 5. And then we just got to do some good old order of operations here. So 3 times 4 is going to give us 12. And then we're going to do 12 minus 5. And that is going to give us 7. Right? So, now, you might be like, Ms. Heil, you don't have to show all that work, and you were right. If you just put the answer, that's okay. You can do this. A lot of people can do this in their heads. You're also allowed to use the calculator. So, now, some things just because you can do it on Desmos doesn't really mean you should. If you are a good math student, this should be no problem to you right here. I realize some of you might be out here saying to yourself, well, I am not a good math student, so I need the easiest way to do everything. Let me show you what Desmos does, because they let us use it. It's like cheating, really. Why will it not do it? Oh, I got to exit the drawing. It is like cheating that they let us use Desmos on everything. But they let us use Desmos on everything. So watch this, particularly if it's a more complicated function. You're going to type f of x equals 3x minus 5 into the first line. Let me make it bigger too. And you do f of 4. And it tells you it's 7. So particularly if you got a more complicated function that you don't feel like working out by hand, Desmos is there for you to evaluate, right? You just got to make sure you got everything typed in right for that. So we've got that. So let's keep going. Oh. What have I got to do? Why is this? I'm losing my mind. Exit drawing. Okay, there we go. All right, so now I said I was going to let you use a calculator on everything. I really don't want to sit our computers back out, and I want to just see where we're at. So, so try these without the calculator. Just a little brain challenge here. Try these 3 right here without a calculator. Operations would be done first. If you parentheses, but there's not any in this one, right? Then it's exponents. So you see that -2 right there? You're going to square it first. So what do you do? So whenever you get squaring something, you multiply it by itself, right? -3 times -3 will be 9. So your next step is 2 times. That's the 9. I'll write it down unless you're extra good. I would just write the rest of it. Well, you could do that next step because you're going to have 3 times -3. -9. Because you got that negative there, it's going to turn into a positive 9. So if you do like minus negative. Yeah. Oh, plus 9. Yeah. Oh, I see. You're already adding that too. Oh, that's fine. You can do plus 11.
Turns into 9, right?
Yeah, but like it's like
Not quite right. What is negative not square? You got square first. So whenever
oh my god, what they said.
separate,
I was thinking about you, sorry. No, I was thinking you had 20 hydrogen.
so you got to add first, which means like right here you have to
Yeah, but then you forgot about this.
instead of doing like 2 times 3 first and then square.
So it's another 9.
That was good. Especially making it different.
And then you add 2.
Whatever you say. You came over here and said, like, so we're not going to let it.
That's what,
So, order, you got the order of operations. You'll have 2 times -3. Wait, mine first. So you got the order of operations first, which is so you want square negative first. Then you want right.
I got negative 7. I don't know how no, but somebody was actually what do you mean? From this right here.
You got exponents first. Alright, I'm seeing a lot of us on the first one have some trouble, and those exponents are tricky on this, especially since I'm making you do it by hand. Rest assured you do get to use the calculator normally, but this is good practice for your brains. My suggestion is that you try to do it, try to do stuff like this without the calculator, then check yourself with the calculator. Because if you always go to the calculator, you won't ever get very good at it. And some of you, might be pretty good at math, and you're maybe wanting to do something like a little math related where you're going to have like pre-cal and some of those classes. So if that's the case, like over there in Miss Martin's in Honors 3, she's making them do all this stuff by hand because if they will struggle in pre-cal if they can't do it by hand. Some too, because pre-cal has big non-calculator sections. So on this first, on example 8, you're going to have 2 times -3 squared minus 3 times -3 plus 2. For that. Order of operations, what do we got to do first? It was, please excuse my dear Aunt Sally or PEMDAS. P is parentheses. E is exponents. We have parentheses, but these are really multiplication parentheses. There's nothing inside of them, right? Exponents is what we got to do first, which means that you've got to square this first. What is -3 squared? It is 9. So you're going to have 2 times 9. And if you want, you can go ahead and do this because it would be the next step. -3 times -3 gives me +9 plus 2. So now I'm looking at 18 plus 9 plus 2. So 18 plus 9 is going to be 27, 28, 29 for that. So you should get 29. I was seeing a lot of you with a 36 right here where the 18 is at because you want to do it that way, right? You want to multiply these two together and then square it because it looks easier to you, but it's not the way to do it. So where are we at on time? Oh gosh. It is time to go. We will finish this up tomorrow, and then we are going to do some practice with it.